Okay, now in today's lecture, we will be continuing from the previous lectures topics, which were mainly the concept of equilibrium. So, the concept of equilibrium says that if any body, any random body, is experiencing some random forces from all directions, let us say F1, F2, and F3. So the directions are randomly given here, and we are following a particular coordinate system code here. Let us say the origin is here. This is the x direction in general, and this is the y direction in general. And this is your body B, which is being enacted upon by three forces F1, F2, F3, which are, let us say, inclined at some angles. Theta for this is given. This is purely vertical force, let us say. This is a vertical force. Theta for this is also given. And it is also given that under the action of F1, F2, and F3, body B is in equilibrium. We already understood the concept of equilibrium. If a body is in equilibrium, most probably the body would be not moving, or the body would be statically staying where it is. And even if it is moving, it should be moving at a constant velocity. If it is rotating, it should be rotating with a constant angular velocity. Under all these conditions, we say that the body is in equilibrium. So once again, I will repeat. If a body B is being acted upon by a certain number of forces or moments also, and it is said that it is in equilibrium, then the following conditions must be satisfied. The summation of the horizontal component of all the forces must be equal to 0. Second condition, the summation of vertical components of all the forces must also be 0. And the summation of all the moments about any point must be equal to 0. So these are the three conditions that must be existing for a body to be in equilibrium. So let us analyze this body. What does it mean if I say that the summation of all the horizontal components must be equal to 0? There are three forces. Out of these three forces, two forces are inclined. One force, F2, is acting purely vertical, or let us say it is acting parallel to the general y-axis. So what you have to do in such cases is, whichever inclined force is being encountered by you, immediately you should resolve it into its horizontal and vertical components. So if F1 is making theta 1 angle with the horizontal, you can resolve this as follows. This becomes the horizontal component, and this will be F1 cos theta 1. And this will be F1 sin theta 1. Similarly, F3 is also an inclined force, which is inclined at an angle of theta 2 with the horizontal. So once again, F3 can be resolved as F3 sin theta 2 vertical and F3 cos theta 2 horizontal. F2 is acting purely vertically downwards, so there is no need to resolve F2. Now, once F1 and F3 have been resolved in their mutual components, then the original F1 and F3 have to be removed from the picture. So what I have essentially done here is, instead of one single force F1 which was acting at an angle I replaced F1 with two forces which are either inclined along the x-axis or inclined along the y-axis. So now in our system, there are only those forces which are either purely horizontal or purely vertical. And this system is exactly the replica of this system. So the forces acting on this system and the forces acting on this system will produce the same resultant. There is no difference at all. But visibly, there is a big difference. In this first system, there are only three forces acting. But in the second system, there are one, two, three, four, five forces acting. But essentially, we know that these four forces have been developed from the original forces which were acting on the body in the first figure. But anyway, now we can easily apply these 3 points of equilibrium. It was already stated that under the action of all these forces, body B is in equilibrium. So if body B is in equilibrium, that means the sum of all the horizontal forces acting on it must be equal to 0. Now apply the sign convention. F1 cos theta 1 is a horizontal force. F3 cos theta 2 is a horizontal force. And there are no other horizontal forces in the system. So if I say that the sum of all horizontal forces must be equal to 0, that definitely means that F1 cos theta 1 with a positive sign. Why? Because this is in the right direction. Then minus F3 cos theta 2. Why the minus sign here? Because F3 cos theta 2 is acting in the left direction, which according to our conventions must be taken as negative. So F3 cos theta 2 with a negative sign. See, what I have done is I have simply added the two horizontal forces which were acting in the system. F1 cos theta 1 horizontal, F3 cos theta 2 horizontal. This one was taken with a minus sign because this was acting in the left direction. And if I put these two forces side by side like this with their sign conventions used, then the summation must be equal to 0. So this is the meaning of applying this condition of equilibrium. So if a body is in equilibrium, the sum of all horizontal components must be 0. And similarly, you have to use the second condition. Now there are three vertical forces. One force is F2 acting downwards. One force is F1 sine theta 1 acting upwards. Another force is F3 sine theta 2 acting upwards. So out of these three forces, these two forces are positive forces because according to the sign conventions, they are acting in the upward direction and which have to be taken as plus sign. F2 is acting downwards and according to the sign conventions, this has to be taken with a negative sign. So if I say that the summation of all the vertical forces must come out to be 0 for the body to be in equilibrium, that means F1 sine theta 1 with a positive sign plus F3 sine theta 2 with a positive sign minus F2. The F2 force has been taken with a minus sign because it is acting downward. Now if I put all these three forces, since there are only three vertical forces, I have put all the three forces side by side using their sign conventions. So basically what I have done, I have added up all the vertical components with their signs, proper signs. So the theory says that this sum must come out to be equal to 0. This is the concept. Now we are not taking the concept of moments, and which we will be understanding momentarily when we take up a real problem from the textbook. So the conditions of equilibrium are applicable on a body if it is not moving, or in the question if it is given that the body is in equilibrium, if it is acting in such a way that it is moving with a constant velocity, or if it is rotating with a constant angular acceleration. In all these conditions, these three conditions must be fulfilled. Now let us get on with a real problem from the textbook and let us see how the conditions of equilibrium which we learned right now can be applied to the problem. Okay. Now look at problem number 2. There is a problem number 1 also. You might be wondering how we directly went on to problem number 2 instead of problem number 1. See, let me tell you one thing before we start this problem. In a particular lecture, even if it was a normal lecture and we were all aggregated inside a classroom and a board was available for me to teach, even in those ideal conditions, it is a very limited amount of knowledge that can be transmitted from the teacher to the students within a stipulated time period of 1 hour. And this being a time of crisis, and all of us not even seeing each other's faces and doing all the studies with the medium of laptops and mobile phones, and instead of a board and chalk I'm using a mouse pointer, and which makes it very difficult for me to draw the figures and lines. And especially when I have to write something, it takes a lot of effort to write sine theta, f1, all these things with the help of a mouse. If I had some stylus or a pen, it would have been very easy. So it's time consuming and wastes a lot of time. So even if we are able to do one or two problems completely, while at the same time transferring all the knowledge to you guys, it takes a lot of time. So the onus falls upon you guys. You have to go to home. I have given you 4 textbooks now. Can somebody confirm and tell me whether you have received all the textbooks, the standard textbooks that I have sent through the Google Classroom media? Can anybody confirm this?
Yes, sir.
So you already have the textbooks with you. And engineering mechanics being a very numerically intensive subject, it's very important for you guys that after every lecture you go open your ebook and find out the other solved examples that are similar to the ones that I teach in the class. Because if I explain one question to you in the Google Classroom,
I need your consent on a few items to continue.
you cannot assume that that would be sufficient for your examination. If you take up the previous question papers of engineering mechanics, you will see that the questions that are asked in the question paper are of very good quality. Some of the questions at least are of very high quality, and you won't be able to do those questions until and unless you have good practice from the textbooks. So once again, I will repeat this very important topic, or very important thing that you have to remember, that the things taught in the classes. I'm not only talking about engineering mechanics, the other subjects also. Whatever is being taught by the teacher is very limited. Your performance in the examination will solely depend on your preparation that is done by solving and understanding at least all the solved problems of one textbook. So out of the 4 textbooks that I have sent you, let us say that you standardize one textbook. Bhavikatti is a standard textbook with which even the other teachers are also promulgating. So let us say others, the first textbook that I sent you among all the others, Bhavikatti is one of the standard authors. So at least all the solved problems of Bhavikatti you have to solve. You must solve. If you do not do that, you always stand a risk of performing very badly in your examination. Is that understood? आप लोगों को भावी कट्टी के कम से कम एक किताब की, आपको 4 किताबें दी हैं, चारों किताब की सारी सॉल्व्ड एग्जांपल्स आपको करने को कोई नहीं कह रहा. एक किताब को सेलेक्ट कर लो सब लोग कॉमनली. लेट अस से भावी कट्टी आपने सेलेक्ट कर लिया, इट्स अ गुड बुक, स्टैंडर्ड बुक, लेकिन भावी कट्टी के सारे सॉल्व्ड एग्जांपल्स आपको एक बार टच करने हैं, कम से कम पढ़ के तो समझ लेने हैं, और तभी आपकी प्रैक्टिस और आपकी प्रिपरेशन पूरी होगी. इज दैट क्लियर?
Yes, sir.
Okay. Now moving on with this example. The question says, find reactions at A and B for the beam shown in figure below. This is the figure. Now, before proceeding with the reactions and what the question is asking, let us understand what the figure is showing you. Okay, this is a straight rod. This double-edged line which is being shown in the figure, this is a straight rod which is resting on two supports, support A and support B. Now, as you can see, support A is not similar to support B. So, first of all, let us understand what kind of support is this. This is called as a pin joint. And what does a pin joint mean? In your textbooks and in your examinations, you will encounter this particular phrase many times, pin joint. Or sometimes the examiner would simply tell you that support A is pinned. Now this is actually coming from the real word pin of English language. Pin means something like this, right? So what is this? They make a joint and insert a pin inside that. I cannot actually draw the pin joint to you. You should preferably go to the internet after this lecture and search for a pin joint on Google. You will get a very good pictorial representation of how a pin joint is made. But the essential aspect of a pin joint is that the reaction of a pin joint is always opposite to the direction in which you apply the force. So let us say a 10 kilonewton force is acting downward. How will the reaction at point A be? It will be directly upwards. Okay. Now let us say I pull this rod in the right side direction with a force of 2 Newton. A horizontal force is applied. Now, since this joint is not going to allow the rod to run away, it is held here with the help of a pin. Okay, it is tied here. So, what will happen? Another reaction at A will be generated. But since this time the force is in the horizontal direction, applied force is in the horizontal direction, the pin joint will generate a reaction in the horizontal direction but opposite to the applied direction. So this will be reaction at A. Now let us understand how will the reaction at A be generated if an angular force is applied on it. So on the rod, an angular force is applied. So what you have to do is, once again, you keep this in mind, whenever, anytime you encounter an angular force, you immediately resolve it into the horizontal and vertical components. And from that point onwards, your solution and your numerical methodology will become very easy. So what I'm going to do is, I'm going to replace this 15 kilonewton with a vertical component. Can anybody put on your microphone and tell me what will be the value of this vertical component which I am resolving here? 15,
15, uh, 13.9.
15 sine 30. This will be the vertical component. And what will be the horizontal component which is acting in this direction? This will be 15 cos 40. Now again you have to remember that once you have resolved the forces into their rectangular components, the original force itself has to be removed from the figure. So once 15 kilonewton has been replaced by its components 15 sine theta 30 and 15 cos 30, this 15 kilonewton angular force has to be taken away and removed. And similarly, this 20 kilonewton has to be resolved into the vertical and horizontal component. And then you remove the original force from the picture. Now, how many forces are being applied in this problem? 10 kilonewton vertical, 15 sine 30 vertical, and 20 sine 45 vertical. This is 20 sine 45. Okay. And this will be 20 cos 45. So let me see whom I have to ask this time. Aviral Sharma, are you listening to me? Aviral.
Yes, sir.
Aviral, please look at the screen and tell me, once I have made all the resolutions, that means all the angular forces have been resolved. Now tell me how many forces are in the system. Applied forces. Count them and tell me.
Sir, can you please repeat? Some network lag has occurred. I can't listen to you.
Okay, I'm asking you to count the applied forces on the beam as seen in the figure. How many forces are there?
Sir, if
Original forces
sir
are
only
removed.
three. Sir,
No,
originally there were three,
originally three, but after resolution, how many are there?
five.
Yes, correct answer. Now you may turn off your microphone. One, two, three, four, five. There are five forces externally acting on the beam. Now, what happens is, since A is a pin joint, A will see, are there any vertical forces acting? Yes. So there will be a vertical reaction also at A. So let us say this is RA. RA is the reaction at point A in the vertical direction. And let us say V also. Now, are there horizontal forces on the beam? Yes, there are two horizontal forces, 15 cos 30 and 20 cos 45. So if external forces are horizontal also, then point A will develop a reaction in the horizontal direction also. Now, many of you might be confused when there are a lot of randomly directed forces existing in the system. How do we decide whether the horizontal component will be acting in the right direction or the left direction? The answer is, it doesn't really matter. You can put the direction according to your whims and fantasies, whatever direction you please. But currently it is highly logical. You see, 15 cos 30 is acting in the left direction, 20 cos 45 is also acting in the left direction. So it is logical for us to conclude that the reaction, the horizontal component of the reaction will obviously be in the right direction. But in case there are a lot of horizontal components, some are in the left direction, some are in the right direction, and you might feel confused, how do I know the eventual reaction would be in the left direction or the right direction? In that case, you randomly pick any direction and put it there. Once we solve the equations, you will automatically come to know whether the direction that you chose was right or wrong. I mean, the equations of equilibrium will auto-correct itself. And if you have mistakenly or unknowingly chosen the wrong direction, the equations of equilibrium will auto-correct you and put your direction in the right side. We will see how it happens. But for now, let us say that these are the reactions developed at point A. Now, the mystery at point B still remains. Point B, if you see closely, is carrying a different type of support. So, as you can see by this small circular part, there is a pin. Pin means this rod is again tied to this support. So, it is not loosely put over it, it is tied at B. But then there are two roller wheels below the B support, and only below that is the ground. This hatched part represents the ground. This is the ground. See, but the support is not resting on the ground simply by putting it on the ground as it was on point A. There are two rollers. Now, what happens if you apply a horizontal force on a roller? It simply acts like a skateboard. जो अपने स्केट्स होते हैं ना, पैरों में स्केट्स पहन लेते हैं, आप हॉरिजॉन्टल फोर्स लगाओगे, the only thing that is going to happen is it is going to move in the forward direction or in the backward direction if the applied force is in the backward direction. So whenever you see a support like this, that means a support which has got two rollers below it. All you have to remember is that this type of support will never develop a horizontal reaction. It is incapable of developing a horizontal reaction. This will never be there for a roller support. This you have to remember. This is very important thing that I am telling you, because when a question is asked in RTU, they will not be telling you what kind of support is being put at point A and point B and all the other places. You will simply be given diagrams like this, and you are supposed to know what kind of support it is and how the reactions at each support are developed. Did you understand the logic of why a simple pin joint will develop both horizontal and vertical reactions, but a roller joint will never be able to develop a horizontal reaction, because any horizontal force applied on the roller joint will make the roller move forward or backward, and hence the applied force will be cancelled out due to the motion of the rollers. The only reaction that can appear at the roller support is in the vertical direction. Did you understand this? क्या ये आपको समझ में आया कि रोलर सपोर्ट पे सिर्फ वर्टिकल रिएक्शंस ही पैदा हो सकती हैं और पिन जॉइंट्स पे हॉरिजॉन्टल और वर्टिकल रिएक्शन दोनों पैदा होगी? Are we clear with this? Please tell me.
Yes, sir. Yes.
Okay. Now, with this point being made clear, let us put the unknown reaction at point B also. So we know that there is a vertical reaction at B and no horizontal reaction because this is a roller support. So let us call this as R suffix B, and there is no need for us to put a V here. V लिखने की जरूरत ही नहीं है. There is no need for us to put a V, because since there is no horizontal direction, there is only one single vertical reaction. So let us simply call it as RB. Now, problem was given as a beam resting on two supports A and B, out of which A is a pin joint, simple pin joint, which develops horizontal and vertical both reactions, and a roller joint which is unable to develop any horizontal reaction, so it will develop only the vertical reaction. And there are applied forces on the beam. Some forces were inclined, and as soon as you see any inclined force, the first step before solving or before starting to solve any numerical is to resolve the inclined forces in their vertical and horizontal components. See the resolution I have directly made, and I am assuming that you will also be able to make a logical component resolution. If a force is like this, then the components will be vertically down and acting leftwards. But sometimes the force will be given like this. In that case, the resolution will be vertically upwards and acting in the right side direction. I hope that this is automatically understood by you and there is no need for me to make it more clear.
Sir, excuse me.
Yes.
सर इसमें जो बी साइड में रोलर लगा हुआ है, इसमें जो ओनली राइट साइड में मूवमेंट तो रिस्ट्रिक्टेड है ना, ओनली लेफ्ट साइड में जाएगा सर वो?
नहीं, ये देखो, बी साइड का जो रोलर लगा है, अभी फिलहाल जो फोर्सेस आपकी एक्ट कर रही हैं वो इस रोलर को लेफ्ट साइड को चलाने की कोशिश करेंगे.
हाँ.
ठीक है, राइट साइड को तो चलने की इसकी गुंजाइश ही नहीं है. क्यों? क्योंकि राइट साइड को कोई पुशिंग हो ही नहीं रही है इस पूरे सिस्टम में.
अगर
आप
फॉर एग्जांपल अगर साइड पे कंपोनेंट होता तो मतलब उसका वहां पे मूवमेंट नहीं होता ना?
नहीं, ये चूंकि इसके नीचे पहिए लगे हुए हैं, आप इस पे ऐसी फोर्स लगाओ चाहे ऐसी फोर्स लगाओ, इसके जो ये जो हॉरिजॉन्टल मोशन है ये उसको खा जाएगा. यानी कि भाई रिएक्शन कब पैदा होता है? रिएक्शन तभी पैदा होता है ना जब कोई चीज रेजिस्ट कर रखी है, ठीक है? जैसे दीवार से, ये देखो मैं आपको इसको क्लियर करता हूं, जैसे एक दीवार है, ठीक है? इस दीवार पे एक खूंटा आपने गाड़ रखा है, देयर इज अ स्मॉल बार ऑफ मेटल विच इज एम्बेडेड इन द वॉल, अंदर तक घुसा हुआ है, और इसको सीमेंट से आपने चिनवा रखा है इसमें। अब अगर आप इसको पकड़ करके बाहर की तरफ खींचते हो किसी फोर्स को अप्लाई करके, तभी तो ये वॉल इसको पीछे को रिएक्शन देगा ना। ये रिएक्शन क्यों डेवलप हुआ? ये रिएक्शन आपके अप्लाइड फोर्स के ऑपोजिट डायरेक्शन में, क्योंकि यहां पर आपने इसको दीवार से फिक्स कर रखा है। तो दीवार जो है इस बीम को बाहर निकलने से रेजिस्ट कर रहा है, एंड रेजिस्टेंस इज इवेंचुअली व्हाट कॉजेज द रिएक्शन टू गेट डेवलप्ड। लेकिन जहां पर रेजिस्टेंस ही खत्म हो जाए वहां पर रिएक्शन कैसे आएगा? जैसे कि सपोज आपने दीवार में एक होल कर रखा है, ठीक है? ये होल है दीवार में, और होल के अंदर सिंपली एक रॉड को रखा हुआ है ऐसे, और वो रॉड ऐसे बाहर दिख रही है। अब अगर आप इस रॉड को बाहर को खींचोगे तो क्या होगा? कोई रिएक्शन डेवलप होगा क्या? देयर विल बी नो रिएक्शन, दिस रॉड विल सिंपली बी पुल्ड आउटसाइड, दैट्स ऑल। वही वही चीज यहाँ पर रोलर्स के साथ में हो रही है। चूंकि हॉरिजॉन्टल डायरेक्शन में ये रोलर्स चल पड़ेंगे, तो इसीलिए इस पे कोई रेजिस्टेंस नहीं है हॉरिजॉन्टल डायरेक्शन में, और इसीलिए इसका हॉरिजॉन्टल रिएक्शन हमेशा जीरो आएगा। क्लियर हो गया?
यस सर।
ओके। नाउ इसमें इन्होंने फिगर दे दिया है, दे हैव गिवन द फिगर and simply asked you to find reactions at A and B without explaining what type of joint is A and what type of joint is B. But diagrammatically, whenever you see a figure like this, what do you call this? This is a simple pin joint. And pin joints have the capability of developing reactions in both directions. But tell me, I'm asking you, I am creating a new beam which has both the supports as pin joints. Both of them are pin joints, okay? And I simply put two purely vertical forces on the beam. Will there be a horizontal reaction on any of the pin joints? What is your answer?
No sir.
There will be no horizontal reaction. So whenever you see a pin joint, it is not compulsory that there will definitely be a horizontal reaction. Horizontal reaction can develop at a pin joint, but provided there is a horizontal component of force acting on it. If there is no horizontal component, then there will be no horizontal reaction also. So in this example, in this new example which I took, if there are only vertical forces acting on the beam, then even simple pin joints will give you pure vertical reactions only and no horizontal reactions. But this is not the case. In the given problem, we are dealing with a set of forces which are both in horizontal and vertical directions. So since there are horizontal forces, applied horizontal forces present in the system, that is why we put a horizontal reaction here. Okay. So in this problem, how many knowns and how many unknowns are there? This is unknown, RAH, unknown number 1, RAV, unknown number 2, RB, unknown number 3. And there are 1, 2, 3, 4, 5 known forces. Now, it is asking us to find the reactions at A and B. So in essence, we have to find RAH, RAV, and RB. How do we do that? Since the beam is neither moving downwards, the beam is neither moving upwards, it is not moving in the left direction, it is not moving in the right direction. In the presence of all these reactions and all the applied forces, the beam is not in motion. This does not even has to be given to you in writing, or it does not even has to be given as a verbal statement. You can definitely see that in if you create an arrangement like this with a pin joint at A, pin joint at B with two rollers below it, and then you apply all these forces. this beam will be unable to move in any direction. And in this situation, eventually you can say that this beam is in equilibrium. So if this beam is in equilibrium, then that means we can apply the first principle of equilibrium. That means the summation of all horizontal forces must be equal to 0. So what I want you to do is, I want you to find the value of RAH by applying this tenet of equilibrium. Do it quickly, please. All of you, please try it out. Apply this particular equation of equilibrium on this problem and try to find out the value of RAH.
Sir, 27.132.
Yes, sir. 27.16.
Very good. The horizontal component is 27.13. If you are getting 27.16 and all, that approximation is acceptable. So this is the correct answer. Those who are unable to do, I will just simply put it in writing so that you can understand and do it later. Summation of FH equal to 0. So how many horizontal forces are in the system? RAH is in the right side direction. So I will put RAH with a plus sign. And since it is a summation, I have to add up all the horizontal components. So plus another force is 15 cos 30, but it is in the left side direction. So I will put a minus sign here. Minus 15 cos 30. Another horizontal force is 20 cos 45, again in the left side direction. So summation plus, but the force is negative, so minus 20 cos 45. And now the sum of all these forces must be equal to 0. So as you can see, by applying this single equation, you will eventually come out with the answer of RAH. Because all the other values are known, you can take it to the other side of the equation, to the right side, you will get RAH. And the correct answer is this, 27.13 kilonewton. Now, out of the 3 reaction forces, 1 force has been found. Now what about the other 2 forces? Now let us say we try to apply summation of all the vertical components is equal to 0. Do it. Just like you did for the horizontal components, now do it for the vertical components. Vertical is RAV, RB, 10, 15 sine 30 and 20 sine 45. What we get out of this is RAV upward direction, so positive. Then add the next vertical force, that is 10 kilonewton, but it is acting downwards. So this is with a negative sign, minus 10. The next one, 15 sine 30, is again acting downwards. So add it, but with a negative sign. Next one is 20 sine 45 downwards. So add it with a negative sign.
31.68.
But the problem is
12.82.
now there is another force RB which is in the upward direction. So plus RB. These are all the vertical forces. Okay. And the sum of all these has to be equal to 0. Now the problem is you have got one equation and 2 unknowns. So this equation cannot be solved. ये solve ही नहीं होगी. ये एक गणित का नियम है ये, कि कितने अननोन है और कितने इक्वेशन है. If the number of unknowns is more than the number of equations, you cannot find all the unknowns. तो आप इस इक्वेशन से आर ए बी और आर बी के बीच का रिलेशन जरूर निकाल सकते हैं, लेकिन दोनों की वैल्यू या किसी भी एक की वैल्यू आप नहीं निकाल पाओगे. यू वोंट बी एबल टू फाइंड. सो व्हाट आर वी टू डू? अब इसको करने के लिए अपन क्या करेंगे? We apply the ultimate weapon, that is the sum of moments of all forces about any point should also be equal to zero for equilibrium. अब ये वाला जो टेनेट है ये अपन ने अभी तक समझा नहीं है और यही सबसे इंपॉर्टेंट है. तो सबसे पहले अपन इसको समझने की कोशिश करते हैं. देखो अपने ये वाली इक्वेशन तो फेल हो गई. दिस इक्वेशन हैज फेल्ड इन गिविंग यू द वैल्यूज ऑफ आर ए बी एंड आर बी. Why has it failed? Were we applying the equation wrongly? No, the equation is absolutely right. But the problem is there is only one equation and two unknowns. So it cannot be solved. That is the problem. So we go to the other remaining equation of equilibrium. And this equation says that you select any point on the beam of your convenience. आपको जो point convenient लगे आप वो point ले लो साहब. तो आप ए पॉइंट ले सकते हो. कोई दूसरा कहता है कि नहीं मेरे को ये वाला पॉइंट पसंद है, मैं ये पॉइंट लूंगा. कोई तीसरा कहता है कि नहीं साहब मेरे को तो इस बीम के ऊपर ही पॉइंट नहीं चाहिए, मैं तो यहाँ पे हवा में लूंगा एक पॉइंट. ले लो, कोई दिक्कत नहीं है. कोई कहता है मैं बी पे लूंगा, कोई कहता है मैं यहाँ पे लूंगा. द पॉइंट इज you can take the point for calculating moments as any point in the plane. It does not even necessarily have to be a point on the system, on the reactions, or on the beam itself. This point can be taken anywhere. But the thing is, you have to intelligently select the point. Otherwise, you will again end up with a situation where there is only one equation and the number of unknowns are more. Okay? A simple fact, a very tricky fact, that if I select a point for calculating moments at A, then since RAH and RAV are both passing through point A, so the moment of these two forces will be equal to zero. Did you understand this? कि भाई मैं ये कह रहा हूं कि आप अगर किसी पॉइंट को ऐसा सेलेक्ट करते हो जिसके अंदर से कुछ फोर्सेस जा रही हैं, तो उन फोर्सेस का जो कि उस पॉइंट के अंदर से गुजर रही हैं उनका मोमेंट तो जीरो होगा, तो वो इक्वेशन में आएंगी ही नहीं. तो इसलिए फॉर इवैल्यूएटिंग दिस पर्टिकुलर पार्ट द बेस्ट सुटेबल कैंडिडेट इज पॉइंट ए. दिस इज वेयर यू शुड सेलेक्ट द पॉइंट. अब पॉइंट को सेलेक्ट करके क्या करेंगे? I have selected point A. Once we calculate this, you will see how this is the wise decision to select point A as the point for calculating moments. Now, how many forces are there, including all the reactions and all the applied forces? 1, 2, 3, 4, 5, 6, 7, 8. 8 forces are there. The point is A. This equation says that select any point of your choice. The point of our choice is point A. Now take the moment of all the forces about point A, add them, and they should come out to be equal to 0. So I will do this here. All of you please pay close attention, because once I explain this, all this has to be done by you alone. About point A, this force is passing through point A, so the moment of RAH about A is 0. RAV is also passing through point A, so the moment of RAV about point A is again 0. Now let us come to the next force, 10 kilonewton. This is vertically acting downwards, but it is at a distance from point A. What is the moment of 10 about point A? Can anybody tell me?
14 kilonewton into 4.
40 kilonewton. How is this achieved? Moment of a force from a point or about a point is actually the product of the force and the perpendicular distance from the point. So the perpendicular distance of 10 kilonewton from A is 4 meters as given in the figure. So the moment of 10 kilonewton will be 40. What is the unit? What is the unit of 40?
kilonewton meter.
Kilonewton per meter.
Kilonewton meter,
Kilonewton
not
meter.
Newton meter. It's kilonewton meter. Now, can anybody recall what was taught in the previous classes and tell me what sign should I use for this 40? Is it minus or is it plus?
It is minus.
Minus plus.
All those who have said minus, they have given the correct answer. Why is it minus? Because again, you have to remember what I taught you. You imagine that this is a rocket and this rocket is tied with a string and held at point A, and you ignite the rocket at the tail end. So the rocket will try to fly in the downward direction, but since it is tied, it will be forced to rotate in this direction, and this is the clockwise direction. Clockwise moments are negative. Okay? So using this logic, what we can say is that the moment of 10 about A is minus 40. Now we come to the next force, and since we have to do summation of moments, so we are simply going on adding plus plus plus. Okay, so plus the moment of 15 sine 30. Now quickly somebody tell me what is the value of the moment and what is the sign of the moment. 15 sine 30 vertically downwards acting at a distance of 4 plus 2. This will
Minus
be
45 kilonewton meter.
this will be minus 4 plus 2 6 into 15 sine 30. Did you understand this? This is the moment. ये जो moment मैंने लिखा है, ये किसी को नहीं समझ में आया हो तो प्लीज बताएं. 6 क्यों लिया? 15 sine 30 is acting at a distance of 6 meters. Okay. 15 sine 30 itself is the force. Minus sign क्यों लिया? Again, since the moment, if you apply the rocket logic, it is a clockwise moment, and clockwise moments are negative. So this is minus sign. Next force. So I add a plus because this is summation. Summation hai. So I add a plus here. Now this force 15 cos 30. What will be the moment of this force? 15 cos 30.
0.
Acting here.
0.
Very good. The moment of 15 cos 30 is 0. Why? Look at the line of action of this force. This is going simply straight. It is passing through point A. So 15 cos 30 will not produce any moment because it is passing through point A. Come to the next force. 20 sine 45. It's a vertical force acting at a distance of 4 plus 2 plus 4 meters. It is acting here. What is the moment? Give it with the proper sign.
Minus 141.84 kilonewton meter.
Okay, I will put it in a simple writing. Some of you are directly calculating, which is a good thing, but I will have to put it here so that everybody sees and understands. So what is the total distance? 4 plus 2 plus 4. What does that make it? 10. 10 meters multiplied by the value of the force, that is 20 sine 45. 20 sine 45. Why the minus sign? Because again, this force and this distance constitute a clockwise moment. Okay. Now the next force is 20 cos 45. 20 cos 45 is a horizontal force. The moment is, what will be the moment? 0. This is 0. So this will again
0.
Will not develop any moment. Why? Because this is acting in such a way so that it passes through point A. So there will be no moments. Now the last force, RB. RB acting vertically upwards at a distance of 4 plus 2 plus 4 plus 2. How much is that? 12 meters. Acting upwards. What is the direction of this moment? Clockwise or anti-clockwise?
Anti-clockwise.
Anti-clockwise.
So this is positive. Yes, sir. So we don't have to use a minus sign. I will simply put RB, the force, multiplied by the distance, that is 12 meters. Have I taken all the forces? Yes. Some moments were zero, and whichever moments were not zero, we have taken up in the summation of moments with their proper signs. So all these moments have been added up, and these should eventually come out to be equal to zero. Now look at this equation. One equation and only one unknown. Can you find the value of RB from this equation conveniently or not?
Yes,
Yes,
sir.
sir, we can find.
18.89.
कितना निकला है बताओ आरबी की वैल्यू. This is the right answer.
18.89
Yes, sir.
kilometer.
Absolutely right. Very good. Those who are able to do it, this is absolutely correct. Now, once you have found the value of RB, RB is also known now. RAH was already calculated by us in the previous equation. Now you can come to this equation, which was a failure earlier. This equation was developed from the concept of summation of vertical forces being equal to zero. But since this equation contained two unknown values, RAV and RB, and there was only one equation, we were unable to process the values from the equation at that time. But now, using the summation m value, you have already arrived at a value of RB. So now you revisit this equation and put the value of RB here. And in this equation now, there is only one unknown, that is RAV. And eventually, once RB is known from this equation, you can calculate the value of RAV from this equation. Did you understand the concept? Did you understand the proceedings of this?
Yes, sir.
So actually, I was not expecting that we would have to spend so much time on this one problem, but as I told you, everything takes a lot of time in an online lecture, and especially when you don't have the proper equipment for writing and explaining stuff. Writing with a mouse, explaining over the mic, and without seeing the faces takes a lot of time, a lot of effort, and even if it's more effortful for you guys also, I understand that. But what I'll do is I'll give you a few more practice questions.
Okay, sir.
You can note this down. Example 3.21 and example 3.22 from Bhavikatti. These problems are very much similar to the one that we have covered here. You might encounter a force like this. If you do not understand what this symbolizes in a beam, you can skip the example, but try to understand. These are solved examples, okay? These are not unsolved examples. So the solution will also be presented in the book. Try to read the solutions and try to understand what is given. The theme should be exactly similar to the one that we have understood here. In the next lecture, we will cover something new which is called as Lamis theorem, and we will try to take up a few problems from that. So this sheet I am sharing with you, this lecture notes I am sharing with you, but we will use the same lecture notes in the next class also. Now please, before quitting, nobody please quit the lecture. Let me check on the attendance aspect. I have already recorded it once, but let me refresh it once again.
Okay, sir.
42 participants are there, 42 are being reflected here also. Okay, now you can quit the lecture and go to the next lecture. Thank you very much.
Thank you, sir.
सर
आज तो एक ही क्वेश्चन पढ़ा है।
भाई ये बुक किसी के पास है क्या?
अरे अपन सर से मांग लेंगे बुक।
ना सर को कॉल करके बोलना है इसकी पीडीएफ भेज दे भाई।
अरे पीडीएफ